Hello again. In the previous tutorial, we talked about Windows kernel executive objects, their function, format, and how they are stored in kernel pools. In this video, I'm going to show you how to use these executive objects in memory using volatility. As a refresher, a kernel executive object is basically the kernel's bookkeeping of an object. These objects could be files, processes, sockets, or any other resource you must request from the kernel. These objects themselves do not contain the actual data. For example, a file kernel executive object will not contain the file contents, but rather the bookkeeping the kernel must do to allow your program to utilize that file. All we are concerned with in this initial point of forensic investigation is to find out what exists on the system. Once we find out what exists on the system at the time of the snapshot, we can then move on to what that item contains. So if we see, for example, that X file was open in X process, we can see based on this initial analysis that it was in use at the time of the snapshot. And then once we see that it's in use, we can go to see what that item actually contains. So for this video, I'm going to be examining a Windows 7 Service Pack 0 64-bit memory image. To give some interaction in this video, I will also tell you to pause the video at a certain point to let you examine the output and see if you see anything suspicious. I'm also going to give a backstory as to why the memory dump was taken to kind of help you know what to look out for. So here's the backstory for the memory dump. Bob works at Company X and has received an email regarding a FedEx shipment. Not knowing anything about the shipment, Bob clicked on the attachment. After clicking the attachment, a black console box appeared, which contained a lot of computer talk. At this point, Bob knew that what he clicked on was not an invoice, but rather something malicious. Bob then commenced to take a memory dump while the application was still running, and then after the dump was complete, Bob then shut down his computer. Bob then gave the resulting memory dump to a forensic specialist in his company or whatever. So, before we actually get to looking at the dump, I want to analyze Bob's reaction to the malicious activity. Firstly, Bob did mess up by clicking on unknown attachments and emails, which could leave him vulnerable. However, Bob was smart, from a forensic point of view, to immediately dump his memory rather than pull the plug, because once he pulls the plug, everything in RAM that was there is gone. So all that evidence is gone. And also, because Bob acted swiftly and dumped the memory while the malicious program was still running, he guaranteed the application will be in memory for the forensic specialist. So since the application is still being used and the process image is in memory, we're also guaranteed that the kernel executive object for that process is going to be in memory. After Bob collected the evidence, he then shut down his computer to prevent further damage. So now that we've had a refresher on correct memory collection, we can move on to the analysis of memory dump. Given the situation above, our best bet is to try to identify the malicious program. Is probably going to just try to identify all the programs on the machine and just try to take a guess based on the names of each program, see if we see anything weird. This is our first time running Volatility, so I'll explain swiftly its installation and basic usage. You can go to this website here and download a standalone version. The nice thing about the standalone version is that you don't have to worry about the many directories and Python requirement of the real version of Volatility. So after you download that and extract it, you have Volatility. And in my case, I've already downloaded and extracted it to this directory here. So if we just issue an ls, right here is the standalone version. That application by itself contains the whole Volatility framework as of 2.6. So for those of you who have never used Volatility, I'm going to try to give the basic formula here of most commands are going to issue to Volatility. So the first part that's typical in a Volatility command is we'll have attack F and we'll give a file name. And what this is the file that is the memory dump that we've taken. And after that, we have a profile, and I'm going to explain profile in just a little bit, and then we also give a plugin to execute. I'm also going to explain that in a bit. But this is the general format that pretty much every Volatility command you're going to issue is going to look like. TACF in your memory dump, TAC profile, select a profile, and plug in. So the first thing to analyze here is the profile. And selecting a profile basically tells Volatility which OS the memory came from. And this is an important step, as then Volatility can then know how the data is structured in that memory dump. So if this memory dump came from a Linux machine, we need to tell Volatility that it came from a Linux machine so that Volatility will know how to look at it. To get a list of all the profiles that exist in your particular version of Volatility, you can do TAC info like I just did here. TAC info, I'll run it one more time. Then we can scroll up, and you see here are all the profiles that exist on the system. In our particular case, I told us that we were using a Windows 7 Service Pack 0 64-bit image. So we'll take this. Come on. We'll copy that, and we can start applying our formula that we have. Volatility, TAC F. Okay, so there's my memory dump there. TAC profile is equal to this. And now we need to select plugin. Going back to our plugin, what is a plugin? A plugin is basically an extension of the Volatility framework. And the reason that these exist is because Volatility by itself is pretty complicated. You actually have to write the Python code yourself to actually step through the memory dump, and that's quite complicated. So the fact that these plugins exist, we can just use this one line and get valuable output back. So the particular plugin that we're going to use in this video is called PSScan. And PSScan is basically just going to scan the memory from top to bottom, searching for the 4-byte tag, capital P R O C. And the process that PSScan is using to scan this memory is exactly the full tag scanning that I discussed in the previous video. So now I'm going to run this command, and it's not going to take it very long to look through this, just because it's only a 512 megabyte disk memory image, and I'm also using a solid state drive. But you can expect that if you have a slower hard drive and a bigger memory dump, that this could take a little while. So now that we have the dump here, this is every process that was on the system at the time the dump was taking. And I'm going to ask you to pause the video at this time to see if you can find which process you think was the application that Bob accidentally executed. Upon initial examination of this memory dump, you may notice a lot of normal Windows processes such as SVC host right here, and there's typically a lot of them on a Windows machine. SVC host, for those who don't know, is just the service container host on a Windows machine. One executable can contain many services, and once that container fills up, we'll get another SVC host. But that's beyond the scope of this video. You also see normal processes like winlogin and min-gw 32-bit G++, which is a C++ compiler. But if you take a closer look, we see this invoice_1337.e, in which, because of reasons I'm not sure of, Volatility, when it prints this out, is going to truncate the name to 16 characters. And at the moment, I have an email sent to the developers to try to figure out how to extend that to a larger range to get the entire name of the file. But this process name here definitely fits the profile that we discussed Bob previously. This very well could be the invoice he clicked on. So since we have, based on this initial examination, we know that this process here is very suspicious based solely alone on its name and warrants further investigation. So in conclusion, in this video, we introduced the Volatility framework from the user's point of view. And using the framework, we analyzed a memory sample from an infected computer and came to a probabilistic conclusion about the process Bob might have clicked on. We came to this conclusion by utilizing the pool tag scanning method when searching for a tag associated with a particular type of kernel executive object. In this case, we were looking for process. We were looking for the specific tag, capital PROC. And similarly, there's other plugins such as PSScan that will search for other executive objects in the exact same way. For example, FileScan will look for the tag. We'll use FileScan will use pool tag scanning to search for every file in the system that it can find, and another one, SockScan, will search for every socket on the system using pool tag scanning. So in the next video, we'll dive into the internal of a process image looking specifically at handles and tokens.